can see me and you can hear me. If yes, type in the comment box. Can you see the screen clearly and can you hear me clear? If yes, type yes in the comment box. Is the screen not visible to you? Yeah, good morning all of you. Good morning Kevin, Krishna, Jagdish and all. Is this clearly visible to all of you? If yes, please write yes in the comment box. Okay, fine. Then we shall start the class. So basically, recapitulating what we have discussed in past two classes. In the first class, I have given you what's the definition of a limit after defining what's called a neighborhood and all. Now, after defining limit, we have seen some standard limits, and after which we have seen some standard curves so that it could be easier for us to analyze limits. And after that, in yesterday's class, I have given you some standard limits, and after that, we have discussed the concepts of continuity and differentiation, and we have seen how the first principle of differentiation was evaluated using the delta y by delta x and all these things. I hope you remember all these things. So in today's class, we'll be continuing basically from yesterday's class, and we'll look into few problems of limits and differentiation. Then we'll go for some concepts like mean value theorems, and if time permits, again we'll visit Taylor's series as well. So the class is from 7:45 to 9:15 a.m. today. So please stay tuned and stay attentive. So in yesterday's class, if you remember, we were going to one particular problem, limit x tends to infinity, x minus sin x divided by x plus cos x. Okay, I hope this is the last thing that we visited yesterday, and we have stopped it at this moment because of few that existed. And I asked you to try this question, and I hope many of you tried this question. How many of you tried this question, and what could be the answer for this? Please tell me what's the answer for this question that we stopped yesterday. No comments. Comment. What's the answer you got for this question? 1. Yeah, good. Ganesh, Vamsi, Suma, Sarath, all of you. Yeah, very good. It's 1. The answer for this is 1. Now let us see how to evaluate such questions. Means basically when there is x tends to infinity and there is a ratio of two functions, f of x divided by g of x, and to be more precise, if they are polynomial functions, then let us see how to evaluate the things. Okay. So before going into this thing, I would like to give you an analysis for this question. Limit x tends to infinity. If I take an x common here, I'll be having 1 minus sin x divided by x in the numerator. Correct? Similarly, if I take x common in the denominator, I'll be having x into 1 plus cos x divided by x as well. So this is the limit that we could make a slight modification by taking the x common. So if you cancel this x all over here, now you can see whatever the value, let me write the things. X tends to infinity, 1 minus sin x divided by x divided by 1 plus cos x divided by x. This is what we have. So when x is tending to infinity, this numerator sin x is a finite value in between -1 and 1. So a finite value divided by infinite value will give me 0, which means when x is tending to infinity, this sin x by x will give me 0 actually. Similarly, the case with cos x, because cos x is also finite range from -1 to 1. So which means this finite value in between -1 to 1 divided by infinity, again this term cos x by x tends to 0 when x is tending to infinity, which means this limit is 1 minus 0 by 1 plus 0, which is 1. Okay, so this is the way to work out this particular question. But now let us try to see when there is a ratio of two polynomial functions and when x is tending to infinity, what could be the case. Okay, so let's look into that. I hope this is a simple question that all of you could understand well. So let us go to the next slide. Okay, yeah, better. So I'm giving you some standard result when x is tending to infinity, means when the variable tends to infinity. What or how could it look like? Limit x tends to infinity, a naught x power m plus a1 into x power m minus 1 plus a2 into x power m minus 2 plus and so on plus am plus f of x, where this f of x is a function in terms of x. You can sense that. Let me erase this part. Let me draw a straight line. here. Today these things are happening. Okay. So see here, let the denominator polynomial is b naught x power n plus b1 x power n minus 1 plus b2 x power n minus 2 and so on plus bn plus g of x. And f of x and g of x are finite valued functions. Let me write here, finite valued functions. What is the meaning of this finite valued functions? Means whatever you put in terms of x, the function outcome is always a finite value which is less than infinite of, which is a finite value basically. Yeah, of course. So for example, f of x can be sin x, cos x, sin square x, cos square x, sin 2x, all these things where function's range is finite. So if you have two such functions like we have seen in the previous case, sin x is sitting on the top and cos x at the bottom. So now the answer for this is equal to a naught by b naught if m is equal to n, means if these two polynomials are of same degree and if this f of x and g of x are some finite valued functions, then the value of this complete limit is simply a naught divided by b naught. Now this limit is equal to 0 if m is less than n, means if the numerator polynomial is of lesser degree when compared to the denominator polynomial, then this will give 0. Is equal to infinite if m is greater than n, which means this limit will go to will tend to infinity if m is greater than n. We'll see how these results are coming in general, okay, when these are finite valued functions. Okay, so let us look into that. Now if you see, the limit we are discussing is limit x tends to 0, a naught x power m plus a1 x power m minus 1 plus a2 x power m minus 2 plus and so on plus am plus f of x divided by b naught x power n plus b1 x power n minus 1 plus b2 x power n minus 2 plus and so on plus bn plus g of x. Correct? Now if I take x power m common from the numerator, this is equal to limit x tends to 0, x power m, if I take it common, I have a naught plus this is a1 into x power m minus 1. So if I take x power m minus 1, if I take x power m common out of it, I'll be having a1 into 1 by x. Correct? Because this x power m, when multiplied with this x, you'll be having x power m minus 1 again. So no problem. Plus a2 into the term that could remain here is 1 plus x, 1 by x whole square, and so on, plus am into this is 1 by x whole power m plus f of x into 1 by x whole power m. This is what we have here. Correct? Whole divided by x power n into b naught plus b1 into 1 by x plus b2 into 1 by x whole square and so on plus bn into 1 by x whole power n plus g of x into 1 by x whole power n. This is what we have. Correct? Now tell me one thing, when x is tending to infinity, yeah, x is tending to infinity, correct? So let me make a modification here. X tends to infinite. This is what we are talking about basically. Thank you, Krishna. So if x is tending to infinity, as x tends to infinity, what about 1 by x? Tell me. When x is tending to infinity, 1 by x tends to, what's the answer? When x is tending to infinity, 1 by x tends to 0. Yes, it's obvious. 0, which means in this limit from here, every term to the right is 0. Yes or no? Because all these are constants, a1, a2, a3, basically they are finite values, and this 1 by x is 0. Then if 1 by x is 0, 1 by x whole square is also 0. Similarly, all these terms are zeros. You may doubt one thing, I told you clearly, this f of x is a finite valued function. So finite value into 0 is always 0, which means this complete limit which we are writing here, if I take this x power m by x power n as x power m minus n, then since all these terms to the right of this plus sign here and in the denominator as well as zeros, I'll be remaining with a naught by b naught. Correct? So which means I have Since this a naught by b naught is a constant, I can bring this out of the limit. Means my limit is a naught by b naught into limit x tends to infinite x power m minus n. Correct? This is what we have, which means the initial limit that we assumed gets converted to this particular format. So now we have limit x tends to infinite a naught by b naught into a naught by b naught into x power m minus n, which is a naught by b naught. If you take it as constant outside the limit, we have a naught by b naught into limit x tends to infinite x power m minus n. I'm giving you this result. It's just a 3-4 steps proof, but it's really important when you deal with limits when x tends to infinite. That too, especially with polynomial functions. So see here. Now this is the result. So now whatever the answer you will get, that answer depends upon this particular limit x tends to infinity x power m minus n. Correct? So if that's the case, if m is greater than n, if m is, or let us first of all consider the case with equal to n, so that you can see the things. If m is equal to n, then this implies m minus n is 0. This implies x power m minus n is 1. Correct? So now, if this is the case, limit x tends to infinity x power m minus n is equal to 1. So when you multiply this 1 here in place of this limit x tends to infinity x power m minus n, a naught by b naught is the answer. So if m is equal to n, limit x tends to infinity x power m minus n is equal to 1. Now what if m is greater than n? See here, if m is greater than n, then this value m minus n could be a positive number, correct? And when x is tending to infinity, x power something positive will give you positive infinity. So limit x tends to infinity x power m minus n is infinite, correct? Because this, when m is greater than n, I am telling you this m minus n is positive, and positive power of this x will give infinity when x is tending to infinity. Means when x is very large number, this positive power to this large number is again a very big number, correct? Now what if m is less than n? Then this m minus n is negative, which means this when m minus n is negative, this x which is infinity comes into the denominator. For example, if you see, you will write x power minus 2 as 1 by x square, correct? So such cases, when this m minus n is negative, this x can be written with a positive sign in the denominator, which means it is of 1 by x form. So your limit tends to 0. Tends to 0. So these are the 3 cases depending upon what's the value of m and n. So I mean depending upon the degrees m and n. So if the 2 degrees are equal, this limit is equal to 1, and the answer will be a naught by b naught. If m is greater than n, then this limit tends to infinity. So constant into infinity is again infinity. So when m is less than n, this value is 0. So 0 into a naught by b naught is again 0. So that's how these 3 results which I have stated here comes. Now with the, okay, I'll give you a bit time, take it. Meanwhile, let me go through the comments if someone didn't understand something. So what if f of x has a degree greater than m? Then f of x into 1 by x whole power m will tend to infinity. Sorry. So what if f of x has a degree greater than m? Then f of x. See, it doesn't depend upon the degree. Basically, it all depends upon the value of the f of x. For example, if you take sin x involves terms which are higher. I mean, sin x is an infinitely extending series. It has terms which are more than, I mean, it goes on. Like x, in yesterday's class, I have given you the expansion for sin x minus x cubed by 3 factorial plus x power 5 by 5 factorial. This goes on. But the problem is, thus whatever the value you put in place of x, the whole function will give you a finite value as an outcome. Okay. So it doesn't depend upon the degree. It depends only on the outcome values of this f of x. Okay, so now you can take this, you can write a word here since m minus n is positive. since m minus n is positive. Here, since m minus n is negative. Vijay Sai, sir, make 2 hours class. Actually, we couldn't because some of the universities are giving their online semester exam courses to their students in the colleges. So we need to plan before 9:30. Okay. Okay, I hope you have taken this. Now, if you know this result means when, this result means if m and n are same, then the answer is a naught by b naught. Now, if you look at this particular question, if you see the degree is 1 here and also 1 here, correct? And these are finite valued functions. So, if both degrees are same, what's the answer? Simply a naught divided by b naught, which means the ratio of coefficients of the higher degree terms. 1 by 1 will give you 1 directly. Okay. So this is how you could solve this question simply if you know that particular things. Okay, so now we have seen this limits, this particular questions on limits. Now next question will go for continuity. Limit extends to 0, 1 by x. Is this function continuous? Basically, no. We have discussed this does not exist as well. This 1 by x function is not continuous at x is equal to 0. Now, I would like to give you few important things regarding differentiability. Okay, the function f of x is equal to mod x is option A, continuous and differentiable, continuous and differentiable at x is equal to 0. B, continuous but not differentiable, continuous but not differentiable at x is equal to 0. Next, discontinuous but differentiable. Yeah, I hope some of you are already getting the answer for this. Answer is option B. Yeah, good. Discontinuous but differentiable at x is equal to 0. Option D could be discontinuous and also not differentiable. I think there's a bit going here. Differentiable at x is equal to 0. So out of these 4 options, what would be the correct answer? Yeah, all of you have done it right. It's B, because you have seen the function is always continuous. Because if you remember the graph of mod x, I was drawing like this. Correct? On the other day, x minus x, y and minus y. This is what we have done, and we see this function doesn't have any break anywhere, and this function is continuous at all points. Now, how to check the differentiability? Yesterday, someone of you was asking, how would we know whether a function is differentiable at a point or not? So let us see that now at this moment. The derivative of f of x at x is equal to a is given by f dash of a, means basically f dash of x at x is equal to a is equal to limit x tends to a f of x minus f of a divided by x minus a. This is what we have written yesterday for the definition of the derivative, correct, at a point a. Now, if this limit exists, then of course this f dash of a exists, and we say the function f of x is differentiable at x is equal to a. Now, for the limit to exist, we have one condition, that left hand limit should be equal to right hand limit, correct? So let us evaluate this particular limit by taking f of x as mod x and point A as 0 because we are trying to see whether mod x is differentiable at x is equal to 0 or not. So here in this particular case, f of x is equal to mod x and A is equal to 0. So now let us try to work out the things. First of all, I need to consider left hand limit. So left hand, here we call this derivative because this is the limit which is a derivative basically f dash of A. So left hand derivative. When I'm considering left hand derivative, this should be A minus, means I should talk, if this is A on a real axis, then I need to talk on the left neighborhood, correct? So limit extends to A minus, f of x is mod x minus f of A is mod A divided by x minus A. Let me write 0 straight away here because since we have taken 0 here already. So let me write 0 in place of A since we already assumed that 0 minus 0. Now this is equal to limit x tends to 0 minus mod x divided by x. This is what we have. Correct? Now tell me one thing clearly, very clearly. I am writing x is tending to 0 minus. Correct? I am writing x is tending to 0 minus. When x is tending to 0 minus, x is more than 0 or it's less than 0? Tell me that. On a real plane, if you consider x as 0, I mean x tends to 0 minus, x is more than 0 or x is less than 0? It's more or less? Less. Correct? Seth, it's correct? Yeah, all of you are writing it correct. It is less than 0. So when x is less than 0, what would mod x look like? I told you yesterday the definition of mod x as mod x is equal to minus x when x is less than or equal to 0, x if x is greater than 0. You remember this? Yesterday we were talking about this mod x function. So now when x is less than 0, as many of you told, can I write this mod x as minus x? Because mod x is nothing but minus x when x is less than 0. If I write that, this is equal to limit x tends to 0 minus x divided by x. If you see clearly, I have removed this minus sign here because I have already modified this f of x, which is minus x, by using this minus sign here. So once you modify the functions depending upon this limit, you need not carry this minus signs here. Correct? So if you see, x gets cancelled and it is minus 1. So left hand derivative means basically the left hand limit of this limit is giving minus 1. Now let us take the right hand limit. Right hand limit. Limit x tends to 0 plus mod x minus mod 0 divided by x minus 0. So if this is the case, limit x tends to 0 plus mod x divided by x. So when x is tending to 0 plus, this mod x is plus x. Correct? So if I write that limit x tends to 0 x by x, the answer is 1. Means in the left hand limit the value of this limit is minus 1 and in the right hand limit the value of this limit is plus 1. And if you see this left hand limit and right hand limit are not agreeing with each other because this is minus 1 and this is 1. So since they are not equal, basically we say that this limit does not exist, which means the derivative of mod x at x is equal to 0 does not exist. But from the graph we have seen that mod x is continuous at every point like this. Correct? So the correct answer for this is mod x is continuous but not differentiable at x is equal to 0, which is option B, which many of you have stated correctly. Correct? So now one important thing I would like to tell you. Now following this analysis, this particular analysis, you got left hand derivative as minus 1 and right hand derivative as plus 1. Now if you see the graph of mod x, yesterday what did I tell you? What's the physical meaning of derivative? It's nothing but slope. Correct? This is what we discussed yesterday. Now see, in the right neighborhood means somewhere here, what is the slope of this mod x? This is the equation of the line y is equal to x. So slope is 1. Correct? Because this is the line y is equal to, this is the line of the form y is equal to mx with value of m as 1. So slope of this line is 1 and this line equation is y is equal to minus x, which means in the left neighborhood somewhere here where this is the curve, the slope of this line is minus 1 and that's what you got here exactly. On the right hand side slope is 1 and then on the left hand side slope is minus 1 because left of 0 the equation of mod x is y is equal to minus x and to the right of 0 the value of mod x is plus x. Correct? Yes. So you can see that minus 1 and plus 1 values here itself and you can see these are the point where the function is not differentiable. Generally, one important thing I would like to tell you, in calculus, functions are not differentiable at sharp points. in some cases you'll be getting sharp points like this where functions are not differentiable basically. Okay, so please make a note of this and take this example. So this is how basically you will check whether a function is differentiable at a point or not. Write the definition of the limit, then substitute f of x and f of a values, and now try to find left hand limit and right hand limit. Then depending on the left neighborhood or right neighborhood, modify these functions mod x as minus x or plus x depending upon this minus or plus signs, then evaluate the limits. If values match each other, means basically these two values, right hand limit and left hand limit, match each other, then we say limit exists. If not the case, we say the function is not differentiable at x is equal to a. Okay, so please take these things. I'll be giving you a minute to take this. And in yesterday's video analytics, I have seen 30% of the viewers are newly searching members, means they are finding this video when they are searching the YouTube. So if you want to have a clear notification at every time we provide live or some session, you better subscribe the channel so you may get a notification. Okay. Fine. Taken? Did you understand why I'm substituting minus x and plus x here? If you understand that part, then the story of this is done. Okay, now I would like to give you a question. Could you try it for me? Okay, see here. The function f of x is equal to modulus of sine 2 pi x by L, where x is on the L axis, complete L axis, and L is a positive number, for example. Okay, it could be a real number in simple case. Is, again, if you go for the options C and D at x is equal to 0, where I'm writing the standard notations. C stands for continuous and D stands for differentiable. And D stands for differentiable. Okay, continuous and differentiable at x is equal to 0. B, continuous and not differentiable at x is equal to 0. Not continuous and differentiable at x is equal to 0. D basically is not continuous and not differentiable at x is equal to 0. What could be the answer for this? I'll give you a good, some of you are mentioning the answer. It's okay. Let's give time for others. So please write over this. Meanwhile, Vijay Sai, I hope you didn't turn A. Okay, some of you are writing A, some of you are writing B. Let us see. Actually, the answer for this is B, but I'll show you in a short time how this is B and all. Meanwhile, someone has a doubt why I am using minus x and plus x here. This is because of the mod x definition. If you see here, x is tending to 0 minus, and you know when x tends to 0 minus, x is less than 0. When x is less than 0, this mod x is nothing but minus x. So in place of mod x here, I have substituted minus x. Similarly, when x is tending to 0 plus, means when x is greater than 0, this mod x is x, which is as per the definition of mod x. Okay, so that's how I substituted minus x when x is less than 0 and plus x when x is greater than 0. Okay, which is I clear? Okay, yeah, fine, good. So see clearly this particular question. You know that mod x is greater than 0 when x is greater than 0, and mod x is minus x when x is less than 0. Similarly, the case with here. If you see the sin x graph, sin x looks something like this. Correct? Means in the right neighborhood, whatever the positive value you have, same value you will be having negative in the same neighborhood. to the left of this, correct? So same logic as for mod x, continuous and not differentiable at x is equal to 0. So to answer these kind of questions, basically I'll give you one simple thing that by which you could answer these kind of questions. If you see, mod f of x is continuous at all points but not differentiable at the points where f of x is equal to 0. And let us suppose this f of x doesn't have a denominator function again, because if there is denominator function we get few complexities again. And let us suppose there is only single like polynomial terms or something like that, trigonometric terms, but this function f of x doesn't have a denominator. Okay, so where f of x is 0. Now, and also f of x is not differentiable at all sharp points. I told you this thing, correct? Now, one of you was asking how this sine 2 pi x by L has sharp point at x is equal to 0, correct? Now tell me one thing. This is the actual graph of sine x, which we have down here, correct? Y is equal to sine x. Now suppose if I ask you to draw graph of y is equal to mod sine x, how would you draw this graph? Tell me. The graph looks something like this, correct? Because whatever there is negativity here, that gets positive because of this modulus sign. So similarly, if you try to draw the graph of this particular 2 pi x by L, this is basically let me make you clear one thing. This divided by L is only here, okay, not completely. Okay, that's a little correction, so please make that. Even though the result doesn't changes, even if, because this L is just a constant out of this modulus, and of course it's not equal to 0. Okay, so this is how you draw. So now here you'll get a sharp point, because when a loop gets repeated, you'll get a sharp point at the intersection of the loops, right? So this is how this function is continuous and not differentiable. Now if you see, if f of x is x, then mod x is not differentiable at all points where mod x is equal to 0, and you have seen mod x is not differentiable at x is equal to 0, correct? So example, if you see, mod of ax plus b is not differentiable at x is equal to minus b by a, correct? Because as per this particular point, if you see, this function mod of ax plus b is not differentiable when ax plus b is equal to 0, and when ax plus b is 0, x is equal to minus b by a. Okay. Similarly, if you see mod of tan x, tan x, for tan x denominator is cos x, and if you see tan x is discontinuous at x is equal to pi by 2, which we have seen in graphs, correct? If you remember graph of tan x, how would the tan x graph look like? If this is minus pi by 2 and if this is pi by 2, the graph look at something like this, correct? And if you see at x is equal to pi by 2, there is a discontinuity, because this tan x is sin x by cos x, and it's obvious when denominator goes to 0, the functions are discontinuous. Because basically at x is equal to pi by 2, cos pi by 2 is 0, and if you see at x is equal to pi by 2, this function is discontinuous. Yeah, it's correct. It can't be differentiable at all multiples of pi. Actually, it's not multiples of pi in this case. This 2 pi x by L should be multiples of pi. Okay. Clear? Take these 3 points. These 3 are actually very important. A lot of times questions are asked in GATE. Okay, I think I'm not blocking the board now. Manoj, you want me to explain the example again? Okay, I'll do that. See here. Yeah, for a function to be differentiable, it should be definitely continuous. That's what we have seen yesterday. Because when x plus h is tending to x, it should have continuous path to follow. Okay. So now coming to this example, if you understand this particular point, f of x is continuous at all points, but not differentiable at f of x is points where f of x is 0. So now sine 2 pi x by L is equal to 0. If you equate this to 0, then this function is not differentiable at the points where x is satisfying this equation, correct? So which means 2 pi x by L is equal to n pi, because you know for all multiples of pi this sign value is 0. So if you cancel this pi, x is equal to n L by 2, and this n can be 0 as well. Okay, so at x is equal to 0, this function is continuous but not differentiable. Generally, functions are discontinuous at the points where denominator goes to 0. Like for example, if you see 1 by x, when x is 0, it goes to infinity. Functions are discontinuous. Okay. Now, so I think we have enough discussion on limits, continuity, and differentiation, and we have seen different problem-solving techniques, how to check whether a function is differentiable or not, or how to evaluate a limit basically, and all these things. So now I'll it's 8:20, so we'll go for one important concept which is called mean value theorems, which is very important for GATE, and you can expect some questions from this as well. Mean value theorems, one of the important topic for GATE. Okay. So now basically in this concept of mean value theorems, we go for 3 theorems. One is Lagrange's mean value theorem, which is also called LMVT. Second thing is Rolle's theorem, which is called RT in short way, and the other thing is Cauchy's mean value theorem. So first, if you look at Lagrange's mean value theorem, I'm straight away going into the theorems here because that's the thing we need at this moment. Lagrange's mean value theorem. It's also called LMVT. Basically, LMVT stands for Lagrange's mean value theorem. Okay, so now what this Lagrange's mean value theorem tells us? Let us see. If f of x is continuous in closed interval a comma b, means if a and b are two real numbers on a real axis, and let us suppose this f of x is continuous at all points within this interval, and f of x is differentiable in open interval a comma b, then there exists at least one value c such that f dash of c is equal to f of b minus f of a divided by b minus a. Okay, so this is what the condition it shows. Generally, many of you might have idea only till this point, but there came questions in GATE where if you know only till this point, you couldn't answer that question, but the question is still from Lagrange's mean value theorem. Okay, so we'll see what the excess part in this means, what this basically this equation is representing. Let us try to see this. Okay, so for that, let me sketch two curves here. This is x, 0, y. Okay, and let us suppose you have a curve, this curve, which is y is equal to f of x, where this point is a and this point is b. Okay, now this is x is equal to a and this is x is equal to b. So if you see it's satisfying all these definitions. F of x is continuous at all at all points in between a and b, and it's also differentiable at every point because it's simply I have done a simple polynomial function, so you could sense the things. Then in between this a and b, they exist at least one value c such that f dash of c is equal to f of b minus f of a divided by b minus a. You can write one more thing here, one important thing actually. I would like to write it with a different ink. One value c in a comma b such that this condition is getting satisfied. Okay, means the c what we are talking about is lying in between this a and b. Okay, so now what does this equation represents? Basically, look here. Let us try to write that. Now, if this is the curve y is equal to f of x, and if this is x is equal to a, what about this point on y-axis? Tell me. If this is a and if this curve is y is equal to f of x, what's the coordinate of this point on y-axis? F of a, correct? This is f of a. Yeah, many of you are writing it correct. Good. Yeah, all of you. Good. So if this is x is equal to b, similarly, what could be this line? F of b. Correct. Now, if I write the coordinates for this, look, let me enlarge the diagram at this moment for you. So you can see the things clearly. See now, if this is point A here, what are the coordinates of point A? Basically, if you have a point x comma y, this distance we denote it with x and this with y. So this point is a comma f of a. Similarly, what about this point b? This point b is b comma f of b. Correct? Do you agree with me? Yes or no? Correct? If this is x is equal to a, then definitely this is f of a, and if this is x is equal to b, then this is f of b, which means this coordinates of this point a are a comma f of a, and coordinates of this point b are b comma f of b. Correct? So now let me try to draw one thing which you could see here. If I join this line, these points a and b with a straight line like this, what is slope of AB here? What is slope of AB? Look, A is a point with coordinates a comma f of a, and b is a point with coordinates b comma f of b. Then what is slope of AB? I'm waiting for your comments. No one could tell me. Look, if this is x1 y1 and if this is x2 y2, what's the slope of this line segment? In yesterday's class we have seen y2 minus y1 divided by x2 minus x1. Correct. So if these are the points, what could be the slope here? F of b minus f of a divided by b minus a. Correct. So f of b minus f of a divided by b minus a. Correct. So which means if you see slightly a bit bottom, this expression slope of AB is same as this which I have written on the right side. Correct. Now what does this f dash of c denote? Geometrically, slope is nothing but tangent, slope of the tangent. Correct. So if you rewrite that, there exists at least one point C such that slope is same as this line joining AB. There can be many. For example, if you see there is another point where again slope is something different. Okay. If you see, these two tangents are parallel to this basic line. So which means there exists at least one point C like this, lying in between A and B, where slope at that point C means basically the slope of tangent that you draw at C is equal to slope of line joining these 2 points. This is the geometrical meaning of this. Okay. So when a function is given, there exists at least one point C such that slope of the curve at that point is this difference f of b minus f of a by b minus a. Okay. There can be many points, and that's why if you remember, I mentioned at least one. There can be many. Okay. how many such C can exist, sir? Depending upon the function, but we can assume there will be at least one. Okay, there can be many, depending upon what's the f of x you are dealing with. Okay, I'll show you. There can be infinite number of C's as well for a given function. I'll show you in an example shortly. Okay, so this is the basic thing of Lagrange's mean value theorem. I hope we can short still a bit. Yeah, now you can see the complete thing, but make this thing very important. This C should lie in between this A and B. Okay, in bracket if you want you can in bracket if you want you can write C belongs to A comma B. Okay, because this C is lying in between A and B. There exists definitely at least one. There can be infinitely many as well. Okay, take this Lagrange's mean value theorem. Taken? Taken this? Okay, good. So today we'll be ending up the session at 9:15, avoiding the university situations. And I would like to tell you one thing, please don't go out, because you know in the number of cases in India has caused even China, so please be careful. Okay, save your lives. Okay, so I hope you have taken this. If not, you could pause this for a while and take the notes. And I hope you are getting the notes in the Telegram channel link that I am providing in the comment box. Please go for that. Now, based on this theorem, there is one result that which could be evaluated. Okay. Second theorem, which is basically Rolle's mean value theorem. Okay, so see here, what is this Rolle's mean value theorem? If f of x is continuous in A comma B, and f dash of x is, and f of x is differentiable in open A comma B, then, and there is one more access condition for this Rolle's theorem, and if f of A is equal to f of B, means if f of x is such that in A comma B f of A is equal to f of B, then there exists at least one point C such that such that C belongs to A comma B and f dash of C is equal to 0. Okay, so this is basically Rolle's mean value theorem. If you see what is Lagrange's mean value theorem, if you remember, f dash of C is equal to f of B minus f of A divided by B minus A. Correct? So in this formulation, if you substitute f of A is equal to f of B, basically here f of B is equal to f of A will give you the numerator value as 0, and this denominator is not a 0 because if A is equal to B, then this interval doesn't exist basically. Correct? So then there is no point of discussing this theorem. So when A is not equal to B but f of A is equal to f of B, this value turns out to be 0, and that's what Rolle stated. But this Rolle's mean value theorem has a very beautiful consequence by which it gave the concept of maxima and minima. And you see, you'll be differentiating the functions and equating to 0 to find the points where the function is maximum or minimum. Okay, so we'll discuss that maybe in the next lecture that we go over here. But right now, this is the Rolle's mean value theorem. So if you want to sense it geometrically, what's happening? So see here, 0, x, y, somewhere here, and now maybe something like this. Let us suppose there is a curve like this, where this is A and this is f of A, and similarly this is B and this is again f of B, such that both f of A and f of B are equal. Then if you see, the coordinates of this point A are A comma f of A, and the coordinates of this point B are B comma f of B. Now, if you draw the line between these 2 points, then slope of AB is 0, since f of B is same as f of A. And as per this Rolle's theorem definition, there exists this point C such that the tangent here is also horizontal, basically equal to this. Okay, so this f dash of C is equal to 0. Okay, since slope of AB is 0. And that's how whenever you get an extreme point like maximum, you will be equating the derivative of f of x to 0. Okay, because y curve is of this shape, it can be this shape as well. Okay, but the only key point is this f of A and f of B should match. See, let us suppose the function is increasing at this point, then again to come back to this point it should start decreasing. We'll be discussing this concept of maxima, minima, and concept of increasing and decreasing functions in the next lecture. So it can be any of these 2 shapes. For right now, consider that the curve should be any of these 2 shapes. Okay. Now, before going for next lecture, let me ask you one thing. Whenever, if you want to find a maximum or minimum of a function, you will find the derivative and equate it to 0. Correct? This is what you do. To find maximum of a function, you will find the differentiation and equate it to 0. But tell me one thing: if derivative is 0, will the function can have maximum or minimum at that point? Means basically at extremum your derivative is 0. But if derivative is 0, is there is an extremum at that point, maximum or minimum? Tell me that. Condition of f of A is equal to f of B. Yeah, there is an additional condition. Okay, you're discussing something there. Okay, so this is how basically this Rolle's mean value theorem look like. Okay, violet color is not visible. Okay, fine, I won't use that from now. You could take notes of this for a while. Yeah, Pavan, by double derivating it and all, we'll see what's happening in the next lecture. Why second derivative should be positive or why second derivative should be negative and all these things. Nagasai, Venkat Nagasai, there is an extreme point if f of x is equal to 0. I hope you mean to say that there is an extreme point if f dash of x is equal to 0. Correct? Let us see in tomorrow's class what's happening. I think if you consider closed brackets at a something Subramaniam, did you ask for a question? Okay, the chart is already moved. So okay, let's continue here. One last theorem before we go for a few problems on this mean value theorems, that is Cauchy's mean value theorem. Cauchy's mean value theorem. Okay, so now Cauchy's mean value theorem tells us if f of x and g of x are two functions that are one continuous in a comma b, differentiable in a comma b, then there exists at least one point C such that g dash of c by f dash of c is equal to g of b minus g of a divided by f of b minus f of a. Okay, so this is what this Cauchy. Okay, you asked me not to use violet. Okay, I'll use a different color. So this is the condition. Basically, if you see, this is application of LMVT for two functions simultaneously. Okay? So if you see, Rolle's theorem can also be is a special case of Lagrange's mean value theorem, and Cauchy's can also be deduced from Rolle's Lagrange's mean value theorem. So that's why if you see, this Lagrange's mean value theorem is called generalized mean value theorem, by which you can go for other theorems. Now in exam, yeah, C exists between A and B, correct? Such that, and also C belongs to A comma B. Okay, C is always in between A and B. That's why it's called mean value theorem, because C is somewhere mean in between A and B. Okay, so see here. Now in exam, they'll be giving you questions, but they won't mention which theorem to use. You should yourself sort out which theorem to use. Now, how to decide which mean value theorem to use for a given question? If you see, Rolle's theorem is a special case of Lagrange's mean value theorem. Correct? So, and you have seen Lagrange's mean value theorem deals with only one function. Correct? And Cauchy's mean value theorem deals with two functions at a time. So in examination, if you have two functions given in the question, go for Cauchy's mean value theorem. If there is only one function involving in the question, then go for Lagrange's mean value theorem. If f of a is f of b, then obviously you'll get Rolle's out of Lagrange's. So no issues. So remember this way, if you have two functions, if you are given two functions in the question, go for Cauchy's mean value theorem. If you are given only one function in the question, go for Lagrange's mean value theorem. Okay? So see. Because for differentiability, we should check both the right hand limit and left hand limit. We couldn't put a closed base here because we can't decide about left hand limits. Okay, so that's why I'm putting this open basis for differentiability. Continuous means basically the function shouldn't have any graph. I mean, any discontinuity in the graph means the graph should not break at any point. And mathematically, if you see that limit extends to a f of x is equal to f of a condition should get hold. Mohan Gandhi, I suggest you to please look into last lecture, lecture 2. So that you could get clear idea what is continuous. Okay. So basically, this is Lagrange's Cauchy's mean value. And I would like to tell you one thing: when I am solving problems, please try to solve. Okay. See, I'm not using any PPT kind of thing or some other thing because I want to write steps along with you so that you'll understand step by step. Okay. So please try problems on your own, and please try using virtual calculator while solving the questions. Okay. So see here. So these are three mean value theorems which we discuss here at this moment. Okay. So now let us try to look at few problems in last 30 minutes of this class. See here. First, the mean value C for f of x is equal to 3x square plus 5x plus 8 in correct, in 11 by 2 comma 13 by 2 evaluated using mean value theorem is dash. This is my question. Pavin, you're asking something? It is possible to use calculus in digital calculator. Yes, you can use. There are a lot of functions involved there. General idea about continuity. Mohan Dev Gandhi. See, the answer is 38. I hope it's not. If you see one thing, Arvind, let me tell you one thing clearly. You have mentioned 38, right? What's the maximum value here that's involved? I mean, what's this interval? 11 by 2 is around 5.5 and 13 by 2 is around some 6.5, correct? And I told you C will always lie within this interval, 11 by 2 comma 13 by 2. And if you see 38 is out of this interval, okay? So please check your calculations a bit. Yeah, like give a general idea about continuity. Basically, continuity means, for example, if you take the value, if the graph of sin x goes on like this without any breaking, correct? But if you take tan x, this tan x graph breaks after every pi by 2 interval. Like if you see, function is not continuous at this point. So this is how you see whether graphs are continuous or not. Continuity means simply there should not be any obstacle in between. It should be a continuous flow in terms of fluids and all. Okay. What could be the answer for this? I would give you some time for this. See, this is function. Now, how many functions? Okay, thank you. So, how many functions are given here? Only one function is involved, correct? And you got the interval. So, when there is only one function, go for Lagrange's mean value theorem. So, apply Lagrange's mean value theorem. We have f of x, you have a comma b values. So, find out C. Vivek Verma, it's 6. Harshita, 23 by 3. No. 6. Yeah, 6 is the answer for this question. Vivek, I'm happy for this. So see here, let us try to apply Lagrange's mean value theorem. Okay. Yeah, 6 is the correct answer. Whoever got 6, I'm happy for all of you. So see here how this should be 6. What is Lagrange's mean value theorem tells us? F dash of C is equal to f of b minus f of a divided by b minus a. Okay, so this implies what is f dash of x? Basically, if f of x is 3x square plus 5x plus 8, then f dash of x is 6x plus 5, correct? So f dash of c is 6c plus 5. Directly, I'm writing this. I hope you can differentiate this well. This is a simple function. Differentiation of 3x square is 6x plus differentiation of 5x is 5. So 6x plus 5. And since we are putting it at c, 6c plus 5 is the answer. Now f of b means 3 into 13 by 2 whole square plus 5 into 13 by 2 plus 8. Similarly, 3 into 11 by 2 whole square plus 5 into 11 by 2 plus 8. Basically, the difference between these two, correct? If you subtract these two things, what could you have here? What's the value of this? Could someone tell me? Or what could be the combined value of this? This minus this. The value of this is 41. Is it, Vivek? Is that 41? What is this value? Oh, combined value is 41. Okay. So basically you're telling the difference between these two values that you got is 41. Basically all these values means f of 13 by 2, this value minus this value divided by 13 by 2 minus 11 by 2 is 41. So 6c is equal to 41 minus 5 is 36. So this implies c is equal to 6. Okay. You can compute these values in a calculator as well if you need, and you can tell the answer as 6. Okay. I hope you can subtract this particular figure from this. Okay. It's a simple some mathematics, some basic mathematics that you could deal with. Now, I have made you to solve this question with a particular intention to show you some result which simplifies this question actually. So if you see, there is something a bit difficulty involved in computing all these numbers, correct? So to avoid this computing difficulty, let us go for the next question. The value of zeta, let me write this symbol clearly. This is a zeta symbol. Okay, the value of zeta if f of x is satisfying, if f of x is satisfying f of b minus f of a is equal to b minus a into f dash of zeta is dash, where, okay, let me give you the function because I didn't give you the function yet. Where f of x is given by f of x is equal to a x square plus bx plus c, and of course capital A is not equal to 0. Means basically my intention is to tell you that this is a quadratic function. Okay, so try this question and try to get the value of zeta. If you see, this f dash of zeta is equal to f of b minus f of a divided by b minus a, correct? Which means it's satisfying the form of Lagrange's mean value theorem. Minus b by a, it's wrong answer. Which is I, please check your calculations a while. F of b minus f of a is equal to b minus a into f dash of zeta, and this f of x is satisfying this condition. Then what's the value of this zeta? If you see, this is the formulation of Lagrange's mean value theorem, correct? F of b minus f of a divided by b minus a is same as f dash of zeta. So find zeta from this function. Water. Okay, minus b by 2a, wrong. A plus b by 2. Saitani, just tell me one thing. A plus b by 2 you have written there. That by 2 is only for b or for a plus b combinedly? Tell me that. B minus a by 2 is wrong. Yeah, you are writing a plus b by 2 means should I confirm this or should I confirm this? Tell me. This or this? One or two? Combined. Yes, correct. So this is the actual answer. So let us try to see this. A plus b whole divided by 2. Correct? So see here. I'll be solving this question now. And for solving this question, let me make this screen a bit low. I hope still you can see the things very clearly here. Okay, so see here, I'm solving this. What is f of x? A x square plus bx plus c. Yeah, I'm happy for all of you. A plus b by 2. So see here, a plus b whole to the divided by 2. Ax square plus bx plus c. So what is f of b here? A b square plus bb plus c. Correct? What is f of a? A square plus ba plus c. Now let us calculate what is f of b minus f of a. F of b minus f of a is equal to, see carefully, this subtracted, I mean this lower term getting subtracted from this upper term means a into b square minus a square plus b into b minus a, and of course this both c's gets cancelled off. Correct? So this is the value of f of b minus f of a, and it's given in the function. This f of b minus f of a is same as b minus a into f dash of zeta, which means f of b minus f of a, which is basically this value. This is given as b minus a into f dash of zeta. Correct? Now if you see one thing, this b minus a, This b minus a is common on both sides of this equation, correct? And since a is not equal to b, because this interval can't be having same limits as lower limit and upper limit, I can cancel one b minus a here, and this b square minus a square will give me b plus a, which means a into b plus a plus b is equal to f dash of zeta. What is f dash of x? Basically 2a into x plus b. So f dash of zeta is 2a zeta plus b, correct? This is f dash of zeta. Basically it's given f of x here, so you could evaluate f dash of x and you can write what is f dash of zeta. So if you see, you can cancel this b on both sides of this equation, and a into a plus b or b plus a is equal to 2a zeta, and I can cancel this a comfortably because I stated here a is not equal to 0, correct? If a is equal to 0, we couldn't have cancelled this, but since a is not equal to 0, we can cancel these two. So this implies zeta is equal to a plus b by 2, which many of you have stated in the option before, correct? Now if you see one thing very carefully, this f of x is a quadratic function, correct? Capital A x square plus capital B into x plus capital C. But if you see the value of zeta, there is no involvement of capital A, capital B, capital C here, correct? Which means the mean value zeta is only depending on this interval limits a and b. Yes or no? So this zeta is only depending on the interval limits a and b, and the value of that is a plus b by 2, which means when your function f of x is a quadratic function, the mean value calculated using mean value theorems is nothing but average of the interval limits. Okay, and now with the knowledge of this, could you answer this question simply? Before, you paid a lot of difficulty in calculating these values and all, you took a lot of time. Now if you know that particular point, then you see this is a quadratic function, and for quadratic function the value mean value c is independent of these values, and it's nothing but average of these two. So c is equal to 11 by 2 plus 13 by 2 whole divided by 2, and this is 11 plus 13 is 24, 24 divided by 2 is 12, and 12 divided by 2 is 6. That's how you can get 6 here, if you know that particular point. Okay, so and this is really important. With many times they give quadratic equations with such kind of numbers to waste your time in examination, but if you know this particular point, you could answer straight away. Okay, so C is a plus b by 2. So please take this. Whoever didn't take this, I'll give you some time. Okay. Did you all understand this example? Thank you, Arvind. It's a time saving technique basically. If you all understand, please write yes. If there is any difficulty, you can write it in the comment box. We could look at. Okay, thank you all. See, it's I need to look at the comments while teaching, so it's not possible to look both the things simultaneously. So some of your comments may remain unanswered. So please don't feel for that. Once I write the look back into the live, I'll answer your comments. Okay. And if you feel the content that we are covering here is good enough, you can click a like button of the video so that you can go to your friends as well, who are your classmates and all these things. Okay. Am I audible? Okay. Please take this. This is a very important result in mean value theorems for this thing. Now I'll give you a question. Could you try it? I would like to give you a question. Could you try it? I hope you're clear till now, till this moment. Okay, so it's still 15 more minutes left. So I want you to understand one more point. So I will give you a question. Okay, shall we go ahead? Okay. Write down the question. Yeah. The mean value C for the function f of x is equal to e power x into sin x minus cos x in pi by 4 comma 5 pi by 4 is dash. Let me erase this part. Is dash. Am I audible to you? Am I audible to you? Okay, fine. So please try out this question. I'll be giving you some time for this. Shall we set a timer for this? Not this. Let's see after how much time we'll be getting first answer. 1.5 pi wrong. Let's see what's the time by which we'll be getting the first answer. Is it pi, sir? Sir, what was the above logic applicable for every quadratic equation? Yes, for every quadratic polynomial you can apply Shamla. 3 pi by 4 is the wrong answer. I'm waiting for answers. Please do the question and tell me the answer. Pi. Pi is the correct answer actually. So at 25 seconds, actually, they not answered it correctly. So I'm going here ahead. So see here, because I told you this question because I want you to put one thing in your mind when you're solving mean value theorems. Actually, for this question, if we reduce size a bit, for this question, options were given in GATE examination. Options were something like this: 0, pi by 3, pi by 2, pi. Okay, these are the options that were mentioned for this question. So now let us try to solve this question. What is f of x? E power x into sin x minus cos x. Correct? Yeah, Tanusha, 0. I'll tell you why this is not 0. Okay, so see here. F dash of x. What is f dash of x? See here. Now we have two functions. E power x is one function and sin x minus cos x is another function. Correct? So if these are two functions, can we apply the product rule of differentiation? If you apply that, first function into derivative of second function. Differentiation of sin x is cos x minus differentiation of cos x is minus sin x plus second function sin x minus cos x into e power x. So if I take e power x common, I have cos x plus sin x here plus sin x minus cos x here, which means this cos x and this cos x gets cancelled. I'll be having 2 sin x. Correct? Which means, can I write f dash of c as e power c into sin c into 2? Can we write this? So this is f dash of c. Correct? Now, since only one function is involved, we'll go for Lagrange's mean value theorem, and f dash of c is equal to f of b minus f of a divided by b minus a. And in this special case, we have pi by 4 and 5 pi by 4. So we have f dash of c is equal to f of 5 pi by 4 minus f of pi by 4 divided by 5 pi by 4 minus pi by 4. Correct? Now, see here. See one thing here. F of 5 pi by 4 minus f of pi by 4. Correct? Which means this is basically your f of x, e power x into sin x minus cos x. So if you calculate e power 5 pi by 4, e power 5 pi by 4 into sin 5 pi by 4 minus cos pi by 4, 5 pi by 4. I hope some of you are using calculator for this, but actually if you see, there's no use of calculator for evaluating this particular question. If you see, this 5 pi by 4 is in the third quadrant. Correct? In third quadrant, sine and cos both are negative and values of both of them are same, which means this f of 5 pi by 4 is 0 because sine 5 pi by 4 is same as cos 5 pi by 4. Correct? Similarly, f of pi by 4, sine pi by 4 is same as cos pi by 4, which means both this f of 5 pi by 4 and f of pi by 4, both these are zeros. So 0 minus 0 will give you 0. This means f dash of c is equal to 0. So this implies 2 into e power c into sine c is equal to 0 because this is my f dash of c. Now one thing is very clear. This 2 is never 0. It's obvious. E power c is also never 0 because for e power c to be 0, c value should be minus infinity. Correct? But if you see, we are dealing only with some finite values of c. So since this e power c can't be 0. Now the only thing that should be 0 is sine c is equal to 0. Now by the time you see this step in examination, many of you might have an intuition that the value of c is 0 because sine 0 is 0, and that's why 0 is given as first option here to take out with you. Okay, but the actual answer is not 0. Okay, so here at this point you might feel like c is equal to 0, but c is not actually 0 because I clearly stated when defining mean value theorems that this c should belong to a comma b. Yes or no? Did we mention this or not? If you forget this c belongs to a comma b, then you are lost at this point, even after doing all these things correctly. Okay, so please take care of this. So when c is equal to 0, since 0 is not lying in this interval pi by 4 comma 5 pi by 4, we look for a c value which is satisfying this equation as well as which is in this interval. And if you see, c is equal to pi is the value which is lying in this interval and also satisfying this equation. So the answer for this is pi but not 0. Okay, so please take care of these little things that you see generally. See, there's only one step difference between these two, but if you forget this point, you'll be losing this question. But it was actually a previous GATE question. Now, did you understand, Tanusha? Okay. So if you're liking the content, I am again telling you, you click a like button on the video so that the reach of this video could be increased, so it could be of help to others as well. Okay. KLV Krishna, please don't do that. Okay, clear till this moment? Now I hope there is time for one last question that we could discuss here. Okay, let me go for that. Shyamala, yes, the logic I explained in the previous question is applicable for all quadratic polynomials. Okay. No, actually, Sanket, we can't say it's by chance it happened, but it need not be the case all the time. Okay. Because this value need not be 0 all the time. Okay, it completely depends upon this 5 pi by 4 and pi by 4. Next, I would like to give you one final question before we leave today, and tomorrow we'll start Taylor series. So see here, the one last question that I would like to give you in today's class. The value C evaluated using mean value theorem for f of x is equal to x cube minus 6x square plus 11x minus 6 in 0, 4 is dash. Options I could give you: 2 minus 2 by root a b, 2 plus 2 by root a c, 2 plus or minus 2 by root a, and d none of the above. The lecture is scheduled till 9:15, so we'll end the class at 9:15. Okay, just 6 more minutes, and out of that 6 more minutes, let me again set the timer for you guys. Let us start. Answer is C. Oh, you're so fast. Okay, so then I hope then there's no use of timer here. See here. Oh, you told pink is not fine here? Okay. I hope it's audible, right? Is it audible now? Okay, let me hold the mic since we are at the finishing of this class. So see here. So what would be the value of f of 0? F of 0 is minus 6. Correct? So now we got f of 4 as 6 and f of 0 as minus 6. And what is f dash of x? F dash of x is equal to differentiation of x cube is 3x square minus differentiation of 6x square is 12x plus 11. So if you write f dash of c is equal to f of b minus f of a divided by b minus a. So this implies what is f dash of c here? 3c square minus 12c plus 11 is equal to f of b minus f of a. F of 4 is 6 and f of 0 is minus 6. So 6 minus of minus 6 divided by b minus a is 4 minus 0, which is 4. So if you simplify this complete equation, this is 12 by 4, which is 3. So your equation is 3c square minus 12c plus 8 is equal to 0. And I hope all of you have achieved till this point. Correct? I hope all of you have got this equation. So if you apply for quadratic equation, you got a standard procedure. X is equal to minus b plus or minus root of b square minus 4ac by 2a, finding quadratic equation roots. So you will get c is equal to 2 plus 2 by root 3 as one root and 2 minus 2 by root 3 as another root. Correct? So now out of these two values, which value to consider? 2 plus 2 by root 3 or 2 minus 2 by root 3? See here. Did you all get these two values by applying the formulation of roots of quadratic equation? Like I hope you know this point. If ax square plus bx plus c is equal to 0 is a quadratic equation, then the roots of this equation are given by minus b plus or minus root of b square minus 4ac divided by 2a. Okay, I hope. So now 2 plus 2 by root 3 and 2 minus 2 by root 3. Now if you see, both these values of c are satisfying this equation. Now suppose if both these values are lying within this interval, then you should look. Yeah, see here. Now, if both these values are lying within this interval, then you should consider both these values, because C belongs to A comma B and C satisfying that equation should also be considered. If you see one thing, you can work out two things from this point. You can calculate what's the value of this expression and value of this expression, and if both are lying in between 0 and 4, then you can go for C. And also one thing I would like to tell you here, without using calculator, you could tell this answer. See here. This value of root 3 is in between 1 and 2, correct? 1.7 around. So value of root 3 is in between 1 and 2. If this is in between 1 and 2, this value is in between 1 and 2 again. That's all. So which means this total value is in between 2 and 4. Similarly here, this value is always less than 2. So this value is above 0. So C is the answer. Or else, if you don't feel this logic a bit convincing, you could use calculator for finding the answers. That's anyhow, it's okay. Okay, so fine. So it's 9:16. We'll end up the session today. So what basically we have discussed in today's class is we have discussed some mean value theorems and basically worked out few problems and few problem solving techniques yesterday. And I'm remembering you, if you like video, please click a like button on the YouTube, so the video goes to a maximum number of people. It could be of help to them. Okay, so yeah, that's all from my side for today. We'll meet tomorrow at again 7:45 a.m. sharp on the same channel of Engineers Hub. Thank you all.